This is the second video on intermolecular forces. Intermolecular forces holds groups of molecules together. There are four types: London dispersion forces, which occur between all types of molecules and is dependent upon the electron cloud. Dipole-dipole, which occurs between polar molecules, or a polar molecule can induce a dipole on a nonpolar. Then there's hydrogen bonding and ion dipole. And we'll start in this video by talking about hydrogen bonding. Now, hydrogen bonding is a subcategory of dipole-dipole bonding. It's very specific. You can have hydrogen bonding when hydrogen is bonded to a fluorine atom, an oxygen atom, or a nitrogen atom. Those are the only three where hydrogen bonding will take place. It is analogous to dipole-dipole in how it occurs. It's just that this is stronger than a dipole-dipole. The partial charges, the delta plus and the delta minus, are greater than expected because of the high electronegativity of fluorine, oxygen, and nitrogen. Now, the name is somewhat of a misnomer. It's not a real bond. It is an intermolecular force, not an intramolecular force. But it is stronger than a straight dipole-dipole. The classic is water. Water has a bent shape, and because it has a bent shape, it has a dipole moment. Because the oxygen is so electronegative, it has a higher partial negative charge. The hydrogen, therefore, has a higher partial positive charge, and they attract each other very strongly, and this can be related to Coulomb's law. So water molecules have London dispersion forces. They technically have dipole-dipole, and they have hydrogen bonding. And if asked to name all of the forces involved, I would list all three. The example of water shows a pure substance. You can have mixtures where hydrogen bonding is involved in the intermolecular forces. And this can occur between an atom containing the appropriate hydrogen bonds to either fluorine, oxygen, and nitrogen, and to an oxygen or a nitrogen with unpaired electrons. Here we have acetone being dissolved in water. The oxygen has unpaired electrons. The water has the capability of forming hydrogen bonds. And as you can see, the partial charge on the hydrogen is approaching the unpaired electrons on the oxygen, and that's a stronger intermolecular force than just a dipole-dipole. And you can see these bonds here, 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 and here. So that's hydrogen bonding. Ion dipole goes even further. This occurs between an ion and a polar molecule. Because the polar molecule has a partial charge and the ion has a complete charge, opposites will attract. The larger the charge on the ion, the stronger the attraction. This becomes very useful in explaining what is called solvation, which is the act of dissolving something. In a generic form, what you see here is a negatively charged anion, and so a polar molecule will approach the anion with the partial positive charge closest to the anion. The reverse is true for the cation. So in a specific case, for example, dissolving sodium chloride in water, you can see that surrounding the sodium ion, you have the oxygens closest to the ion because opposites attract. And for the chlorine, the same thing happens. But since chlorine is an anion, it has a negative charge, the hydrogens surround the chloride ion. So to review, in order to have hydrogen bonding, the hydrogen must be intramolecularly bonded to either fluorine, oxygen, or nitrogen. It really is a subcategory of the dipole-dipole intermolecular force, and it can occur between the partial positive and partial negative of a specific molecule if a pure substance, the classic being water. It can occur in a mixture when the hydrogens bonded to either fluorine, oxygen, or nitrogen can interact with the unpaired electrons of oxygen or nitrogen. An ion dipole force occurs between a fully charged ion and the partial charge of a polar molecule. The strength of this force is proportional to the charge of the ion, and it's very useful in describing solvation. In the next video, we're going to begin to use intermolecular forces to explain states of matter and various properties.